Alright, so in this video we're going to take a look at operator overloading in C++. And let's start with a couple of examples. So the first example we have here, we see that we have the integer x and the integer y, or int y and int x. And x has the value of 6 and y has the value of 4. So if we were to see this particular expression here, where we have x plus y, we know that we're doing a summation here between x and y. So that would result in the value of 10 if we were to do x plus y. Let's take a look at another example. Here we have two string variables, a and b. So the first string variable we have, a, has this particular string hey, and the string b here has the string everyone. So if we were to see a plus b, we know that in this particular case, since we're dealing with strings, this plus operator here is actually performing concatenation. So because our arguments here are different, this takes on a different meaning. So behind the scenes, we already have what's considered to be operator overloading. So what that means is, dependent upon what arguments we have for a particular operation, we can have different sort of computations going on. In this case, we have concatenation between two strings occurring. Let's take a look at another example here. So here we have a couple of player objects being created. And I'm not going to specify what the details are of the player class. Let's just assume that in order to construct a particular player object, we have to specify maybe a name, an age, a strength, and an intelligence. So each one of these has a name, a strength, a name, age, a strength, and an intelligence. So if we were to go in and do P1 and then have our plus operator P2, we really don't know what that means. We'd have to go in and define what this particular plus symbol means whenever we have two player objects. So P1 and P2 are player objects. Same thing with P2 and P3. It may be the case that we're doing some sort of mathematical computation based upon their age, their strength, and intelligence for us to actually add these two particular players up and come up with some particular value. We don't know, but we could define that, and that would involve overloading this particular operator, the plus operator, for the type player. So I have some of the commonly overloaded operators specified here, such as our assignment operator, our operations for various mathematical or traditional mathematical operations, addition, subtraction, multiplication, division. Of course, these could take on very different meaning depending on what objects we have. Same thing for our shortcut operators, our comparison operators, and even our insertion and extraction operators. So if we wanted to be able to do cout and then specify a player object, then we could overload the insertion operator for the player class or whatever class it is that we may have. Alright, so let's take a look at what the function prototype would look like if we were to overload the assignment operator for a class called myClass. Basically, we would return a reference to a myClass object. That would be the return type specified. Then we'd have the keyword operator, and then the operator that in fact we're overloading, which is the assignment, and then open paren, and then we'd have a constant reference to a myClass object. Again, myClass is the thing that we're actually overloading the assignment operator for, and then some particular identifier. The identifier that I've used here is RHS, indicating right-hand side. So maybe this will make a little bit more sense if we look at an example. So here, assume that we have two myClass object x and y. So we have x and y here, y on the right hand side and x on the left hand side. So whenever we think about this overloaded assignment operator, really what we should be thinking about is this, where we have x performing this overloaded assignment operation. So we can imagine that this particular function here that we've overloaded, operator assignment, is being invoked on this object x, and y is what we had on the right hand side. It just simply becomes an argument here to this particular function. So if we go back and look at our function prototype, y is mapping up to what we had here in parentheses, and x is the object that's actually having that operation performed on. Hopefully that makes a little bit more sense. So again, just to emphasize, the function that we had for overloading the assignment operator is being invoked on the object x. And why do we need to return, or what do we need to return? We've already specified what the function prototype is, so we know it's a reference to my class, but really why do we need to return that? So let's take a look at an example. Let's assume that we have A, B, and C, and they're my class types. And we were to do this particular operation here. So traditionally, we think of the assignment operator as being right to left associative as opposed to being left to right associative. So what that means is we would perform this particular operation here before we perform this operation here. So we'd be assigning this value of C to B, and then whatever that quantity would be to A. So the first thing that would happen is we would have this particular operation occurring here, where the overloaded assignment operation is being performed on this object B, and C is just simply our argument. So that thing there should be returning a reference to B so that it can become the argument to this particular operation here, which is our assignment from B to A. So the reason why that we need to return a reference to a my class object, whatever that class may be, is so that we can do this type of chaining. So chaining is very important. So without returning a my class or reference to a my class object, we would not be able to chain the operations. So let's take a look at something we should have to consider whenever we write an overloaded assignment operator. So what would happen if we were to do self-assignment, where we had X assigned to X, and X was of type my class? So X could in fact have a lot of data members, or maybe just a few data members, but if one of those data members there was a pointer that was capable of referencing heap space, we'd have to be very careful, because typically what would happen here is that we would deallocate this particular heap space. So we would deallocate this particular heap space associated with what we had on the left-hand side, so that we could, in fact, allocate or assign, the heap space that's associated with whatever we have on the right-hand side, whatever this particular my class thing may be pointing to out there on the heap. Problem is, in this particular case, is that we have both the same thing on the left and right-hand side. So if we were to deallocate first what we had over here on the left-hand side, then that's also deallocating the very same thing that this thing is pointing to. So we would no longer be able to reference this particular thing out there on the heap. So we don't want that to occur. So we have to be very careful. So usually one of the first things that you have happen whenever you're writing an overloaded assignment operator, in the cases where you're referencing something out there on the heap, is that you would have to go in and check for self-assignment. So the way that we could go about doing that is you could do a test like this. If this, and remember that this is just referring to the calling object like X, checking to see if that's equal to the thing that we're referencing on the right-hand side, or the thing that we have on the right-hand side. So if these two match in terms of their addresses, so this is just simply a pointer that holds an address, and this here would be specifying the particular address of whatever we have on the right-hand side. If that's the case, we really shouldn't do anything else, and we should just simply return or dereference this so that we're returning that my class object, and that would be returned by reference according to our function prototype. If that is not the case, then we can go down here and assign whatever we have in terms of the data members on the right-hand side to the left-hand side, and also ensure that we do a deep copy as well, and then return the dereferencing there of this, so returning that my class object. Probably a little bit better way to do this, so that we're not doing the statement of return dereference this twice, is to check for this not equal to what we have on the right-hand side. So we're just checking to see if whatever we have on the left-hand side is not equal to what we have on the right-hand side, and then performing the correct assignment operations and doing the deep copying, and then finally returning the particular my class object by reference. Okay, let's take a look at one more example. So let's look at this example here where we're making use of the insertion operator, and we have cout and we have X. Well, it depends on what X is. If X is one of our primitive data types, our data type that we have defined by the standard template library, then we probably already have this particular insertion operator overloaded for that particular type, but it may not be the case. So let's take a look at the function prototype for overloading the insertion operator. What we'll be returning in this particular case is just simply a reference to an OStream object. And then we'd have the keyword operator and then whatever operator, in this case we're talking about the insertion operator, and then the actual arguments. So what we'll supply here in terms of the arguments to this particular operation is a reference to the OStream object, such as cout, and then for our other argument it will just simply be whatever we're trying to output or send to the OStream. In this particular case we're talking about a myClass object, and we would pass that in by constant reference since we wouldn't actually be manipulating the particular object. So let's take a look at what the body of the overloaded insertion operator would look like. Basically in the body we'll just be building up an OStream object based on the data associated with whatever we've passed in for our second parameter. So in our case we were talking about a myClass object X, and what would be returned by this particular function would just be a reference to an OStream object. And the reason why we need to return a reference to our OStream object is so that we can do something we had specified before, and that's the idea of being able to chain things together. So we want to be able to write expressions here where we can use the insertion operator multiple times, and if we're not returning a reference to an OStream object, we have no ability to do this chaining. So in the next video we'll look at writing the overloaded insertion operator for our VPET class, and we had discussed the VPET class whenever we first introduced the concept of writing our own types, so defining our own classes. Alright, so that's it for this video.